Hello everyone. Today we'll discuss about correspondence analysis. So you can see here, this is our outline. These are our agenda points. What is correspondence analysis? Second, what are the objectives of correspondence analysis? Third, what are the assumptions of correspondence analysis? Fourth, correspondence analysis versus multidimensional scaling. And at the end, we will consider a case study related to correspondence analysis. In fact, we will discuss two case studies related to correspondence analysis. Now you can see here what is correspondence analysis. Correspondence analysis is used to examine the relationship between two nominal variables graphically in a multidimensional space. It is just like multidimensional scaling. In case of correspondence analysis also, we graphically represent the variables in multidimensional space when our variables are in nominal scale or in nominal category. Now, second point you can see here, what are the objectives of correspondence analysis? So, the first objective here, association among only row or column categories. So, in case of this correspondence analysis, we can find out the association of the variables only in the row category or only in the column category. And in case of second, we can find the interaction effect between the row and column. So these two are the objectives of correspondence analysis. We can find out individually for row, individually for column, or we can find out the association between both row and column. That is our interaction effect. Then what are the assumptions required for correspondence analysis? First, it is saying the non-metric data. So our data should be non-metric, that is in nominal scale, and the data should be cross tabulation, that will be in the rectangular table. The data should be there, and we should consider the large sample size for this study. More than 200 sample size we should consider. And the third point, it is saying we should consider the weight cases of data. When we collect the data, we collect the frequency, yes no type question, from where we collect the data. Then we find out the frequency, and that frequency you have to convert it into the weight cases so that it will relate the products and the attributes, and it will relate the two variables. So that's why we have to consider the weight cases, so that for the each variable or the each product, it should define the weightage out of 1. Now you can see what is the difference between correspondence analysis and multidimensional scaling. So the first parameter we are discussing is display. So in both the cases, in case of correspondence analysis as well as in case of multidimensional scaling, in both the cases there will be multidimensional display in case of correspondence analysis also, and in case of multidimensional scaling. The second, this is a major difference. I have put it in red color. You can see here the scale required for correspondence analysis is nominal, and it should have two categories, yes no type question. So it should have the two categories, whereas for the multidimensional scaling you can do it for ordinal scale, for non metric multidimensional scaling, or for the metric multidimensional scaling you can take interval and ratio scale. So in short, you can say like all the three types of scale, ordinal, interval and ratio. If your data is in these three types of scale, you can use multidimensional scaling. And if your data is in nominal scale with two category, then you can use the correspondence analysis. Now the dimensions, the third parameter we are talking about the dimensions. So in case of correspondence analysis, the dimensions are given. So and we want to reduce these dimensions. Already the dimension means the attributes are given here. But in case of correspondence analysis, whereas in case of dimensions to be analyzed in case of multidimensional scaling. So predefined dimensions are not there in case of multidimensional scaling. Later on we define the dimensions. Now in case of correspondence analysis, what we find out? In the relationship parameter, we find the relationship between the two nominal variables like the brand and attributes, products and attributes. Such type of relation we find out, and we see what is the strength of relationship. Whereas in case of multidimensional scaling, we find the relationship between the two brands, you can say that the two products, you can say. So in which there are comparison is not there like this brand and attributes. Here only we find the relationship between the two products or the two brands. Now in short, if we say what is correspondence analysis? Correspondence analysis we have to use this there is a use of exploratory factor analysis, plus it is a multidimensional scaling with nominal scale. So same characteristics are there of multidimensional scaling but with nominal scale. Now the research design for correspondence analysis, how our data should look like. So require only rectangular data matrix, that is the cross tabulation. You can see here in the vertical column, these are our attributes. In the horizontal, these are our brand names, that is the Oppo, Vivo, Samsung, MI and Micromax. These are our different smartphone brands and these are our attributes of smartphones. So we want to find out the relationship between attributes and brands. We can find out like user friendly related to the row wise relationship, user friendly of all the brands, and then related to the camera, or you can say that the Oppo, how Oppo is relates to user friendly, great camera, long lasting battery and all these things. And then finally you can find out the association between all the attributes and all the brands. So you can find out row wise, you can find out column wise, and also you can find out the interaction effect between the brands and attributes. Now once we'll collect the data, we have to prepare the data preparation for correspondence analysis. How we will prepare the data? In the first variable you have to define, like if you have taken the brands, then you have to put the brand's name. In the first variable you will define, that is the brand or brands or the products. The second variable you will define, that is the attributes or the variables, and the third will be the frequency. So these are the three variables you will define in the variable view of SPSS. First one is the brands or products, second is the attributes or variable, third is the frequency. Now you can see here we are considering a case study related to this correspondence analysis, brands of smartphone and their attributes. So what exactly our case study is, you can see here. A smartphone company wants to know about the perception of the customers on different brands of mobile phones on the basis of various attributes of mobile phone. The company has collected data from the customers on the attributes as user friendly, the first attribute, a great camera, second, long lasting battery, third, after sale service, fourth, crystal clear display, fifth, enough storage space, sixth, and then the competitive price. So these are the 7 attributes we have. On the basis of that we have collected the data. And what we have asked to the customers, the data has been collected on the 2 categories, nominal scale, that is yes or no, on the attributes of different brands of mobile phones. So we are asking the customer, like we are taking one mobile phone brand, that is the Oppo. We are asking like, is Oppo is user friendly or not? Yes or no, he has to reply. Similarly for the other attributes and so on for the other brands of mobile. So this is our case study related to correspondence analysis. Now we have converted this case study in the form of a topic. So what we have done, you can see here, perceptual mapping of smartphone brands and their attributes. Perceptual mapping we are doing, it means that there will be a multi-dimensional space in which the brands and attributes will be displayed, so that we can see these brands, how these brands are related, an empirical study. So perceptual mapping of smartphone brands and their attributes and empirical study. We have converted the case study in the form of a topic. Now you can see here there are the 3 objectives we have defined. The first objective is saying to study the comparable brands of smartphones and their attributes. We have written one word, it is the comparable brands, mean what? The same category, like you cannot compare with Nano and then Mercedes. So the same type of brand you have to take, so that you can easily compare the brands with the attributes. Second, to study the association between smartphone brands and their attributes. We'll find out the relationship or the association between the smartphone brands and their attributes, means which brand will relate to which attribute more. So that we try to find out. And the last one, to find the multidimensional display of the smartphone brands and their attribute. So in the multidimensional space, we will find out the brand as well as the attributes. How one brand is closely related, to which type of attribute. That we can see in the multidimensional display. Now you can see here how you will collect the data, how you will ask the questions to the respondent. So you can see here, I have given one example, like please tick mark on yes or no, only one, either you have to tick mark yes or no for the Oppo smartphone. So we are asking the customer, is Oppo smartphone is user friendly? If that customer feels it is user friendly, then he is tick mark on yes. The second question we are asking, a great camera is there in Oppo phone. If he feels yes, then he is tick mark. Is long lasting battery is there in Oppo phone? So he is, if he feels yes, then he will tick mark, otherwise he will tick mark no, and so on. So we have written all the 7 attributes. Similarly for the second, that is the Vivo, similarly the third brand and the fourth brand. So we have to put these questionnaires, either you can put it in the Google form, or you can hard copy, you can collect, you can give hard copy to the customers or the respondent, and you can collect the responses. And once you will collect the responses, you have to count that. Suppose there are 100 respondents have given the responses, so you have to see, like for the Oppo user friendly, how many out of 100, how many said yes. Suppose 70 people said yes, 30 said no, so you have to put 70. So you have to add all these values, so the 70 will be there. Similarly for great camera, it is 40 will be there. If 40 out of 100, 40 people have said yes, and so on. So you can make a frequency table like that. Now you can see here, this is the frequency table we have got from our questionnaire, the data we have collected. You can see here the Oppo, Vivo, Samsung, MI, Micromax. These are the brands, different brands of a smartphone, and these are the attributes, user friendly till competitive price. So what we have done, so user friendly Oppo is 56, means what? The 56 people said that the Oppo has the user friendly attribute is there. Similarly 48 said the great camera. Like what is the 3 after sale service for Samsung? Only 3 people said that the after sale service is good in case of Samsung, and so on. These are the meaning, different meaning, whatever the value we have. These are nothing but the frequency value, the yes value we have taken. So we have added all the yes value and we have got this particular rectangular table. So this is the thing. Now we'll go to the next part. So this is the case study second. So before we'll go to case study second, we'll go to the data of first case. So we'll go to our SPSS file. You can see here, this is our data. So you have seen our rectangular table, but you cannot import that rectangular table directly to the SPSS. So you have to prepare the data in SPSS, and for that you can see in the variable view, first I have defined 3 variables: brands, then attributes, and then frequency. These 3 things are there in my rectangular table. Now how many brands I have? So I have in values I have defined the brands. So you can see here how many brands are there. 1 I have put this Oppo, 2 is equal to Vivo, 3 is equal to Samsung, 4 is equal to MI, and 5 is equal to Micromax. So there are 5 brands are there. So I have defined this, and it is a nominal scale. Second, the attributes, we have seen there are 7 attributes are there. Again I have already defined this thing. 1 is equal to user friendly, 2 is equal to a great camera, 3 is equal to long lasting battery, 4 is equal to after sale service, 5 is equal to crystal clear display, 6 is equal to enough storage space, and then 7 is equal to competitive price. So I have defined all the attributes into different values. So you have to prepare the data like this. For correspondence analysis, you cannot directly import the table. Now we'll go to data view. So in our data view, you can see here, these are the brands, and then if you will click here, you will find this. So you can see here Oppo, Vivo, Samsung, MI, and Micromax, 5 brands. So first we have taken the attributes, user friendly attributes for all the 5 brands, and then we have put the frequency value from the table. Second, again we have started with Oppo to Micromax, and then we have taken the second attributes and we have taken this frequency of the second attribute. Similarly for the third one, fourth one, fifth one, and then if we'll go down, you will see all the attributes are there, and our last attribute was competitive price. So for all the attributes in the first space, the brand name, second is the attributes, and the third is the our frequency. So these are the data we have. So you can see here, if we'll click here in the number, you will get the number value. Okay. Now we'll do correspondence analysis. So we'll go to analyze, and in analyze we'll go to dimension reduction. In dimension reduction you will find this correspondence analysis. You can see here in analyze, dimension reduction, and correspondence analysis. So we'll click this. Now what we'll do, I will put this brand into row. Then you can see here there are question marks here. So I will define the range. So we know that we have 5 brands. So I will put minimum is equal to 1 and maximum is equal to 5. These are the values we have put for Oppo, Vivo, Samsung, MI and Micromax. And then you update this and then continue. Second, I will take these attributes into the column, and then again question marks are there. We'll define 1 to 7 because we have 7 attributes, and then I will update it and then continue and then continue. Okay. Now we'll go to model. In model you can see here by default you will get dimension in solution is 2 because it is very difficult to show the 3-dimensional, 4-dimensional space, multi-dimensional space. So by default you will get 2 dimensions. In most of the cases we consider 2 dimensions. And as our data is in categorical nominal scale, so we will take the chi-square distance, you can see here, and it is symmetrical. So we'll continue. Then we'll go to statistics. In statistics you can see here correspondence table, overview of row points, overview of column points, and then you can say the row profile and then column profile, and then continue and then continue, and then plot. In plot you can take the row points and the column points, and then you can continue. But one thing we have forgot to add, that the data is not in weighted cases. We did not converted the data into weight cases. So we'll see how without weight cases what are the results we are getting. So we'll do it. Okay. So we'll see in the output. You can see here in the output. In the output we are not getting any much result are there. So we are not getting the multi-dimensional space, and all these things are not there. Only we are getting this table, correspondence table, row profile, column profile, but the chi-square value, all these things we are not getting. Why we are not getting? Because we haven't converted the data into weight cases. So how we'll convert it? I will show you. We will close this. First we will convert the data into weight cases. So for that we have to go to data, and in data you have to go to weight cases. You can see here weight cases, and then in weight cases you have to take weight cases by. So click weight cases by, and then frequency you have to take it on the right hand side, and then OK, and then OK. So now you can see here the weight by frequency. So the data is converted into weighted value. Why we are doing it weighted value? Because in the frequency these are the individual value. So we have to find out the relationship so that the total weightage, the probability value is 1. On the basis of that it is finding the association between all the brands as well as all the attributes. Now again we will go to our data. Again, this is the second data we have. Again will this is our data. You can see here brand, attributes and frequency. So this is our data. Now again we'll go to analyze, and then we'll go to dimension reduction, and then correspondence analysis. Already we have put this, the brands and then attributes, and in the model once again we'll check to chi-square, it is there, and then again you can see here the statistics, overview, row profiles, column profiles, it is there. Then plots, you can see here biplot. Biplot means the interaction effect, row and column. And if you want the individual row wise, then also this is the row points, and then column points you can find out. And then continue. Now we'll do OK. Now you can find this output. You can see here. I will show you, once I will show you this output, In this output we are getting this multi-dimensional space also. Earlier it was not there because we haven't taken this the weighted value. Now we'll explain one by one all the table. The first table you can see here. The first table is nothing but the earlier table, whatever the table we have got from the respondents. So these are the frequency 56, 48, 64, 41. This is the first table, whatever we have got. This is the frequency table. So this is, if you will add all these values, you will get 329. Second, 308, 114, 179, 87. If you will add in the column wise, you will get 151. 115, 191, 152 and so on. So these are the values. These are the simple addition row wise and column wise. So these are known as the active margin. The total value is known as the active margin. Now you can see here in the row profiles. So how we have got this value 0.170. 170 you can see here 170 from where we have got this value 56 divided by 329 total value. So it is 0.17. So the weightage of Oppo for user friendly it is 17%, 14.6% and so on, and the total will be 1. Similarly for it is the Vivo 65 divided by 308, then it is 0.221, and then this is the value, total value and so on. And this is the mass function. You can see here the total. If you divide 159 divided by 1017, then you will get this value 0.156. So this is the total mass function of this user friendly, then this is for active margin and so on. So this is the same thing, this is for the column wise. From where we have got this 0.352, 0.352, you can go to the here in the second table. If you will divide 56 divided by 159, then you will find out 0.352 and so on. Similarly, you will find all these values, and then the total weightage you are getting 1. So the total probability value, the active margin will be 1. Okay, so these are the simple calculation. Then you can, this is our main table, is this is the summary table you can see. Now the correspondence analysis is also known as the dimension reduction. As we have found this option correspondence analysis in dimension reduction. So and I have told you that the correspondence analysis is equal to exploratory factor analysis plus multidimensional scaling with nominal scale. So in exploratory factor analysis, what we do? The dimension reduction. So it is reducing and it is bringing how many dimensions? There are 4 dimensions, and this is the for each dimensions you can see here, these are the our correlation value. These are the correlation value for dimension 1, for dimension 2, for dimension 3 and for dimension 4. So these are the correlation value we have. Okay, and then if we will square this value 0.365, you will get this value. Again 0.206, you will get this value. 0.173, you will get this value. 0.082, you will get this value, and this is the chi-square value. This is the chi-square value. Chi-square value. Why? Because we have the nominal scale for both the data, and this is the significant value. What does it mean? It means that there is an association or relationship between the brands and the attributes, because in chi-square there is no relationship, or both the variables are independent to each other and both the variables are dependent to each other. So there is a significant difference. It is less than 0.05. So there is a relationship between brands and their attributes. Now you can see your 0.627 accounted for how many this dimension, first dimension, how many percentage it is explaining. 0.627, 62.7%. Second is the 19.9%. So from where we have got this value? If you will divide 0.133 divided by 0.212, then you will get this value. Second, if you 0.042 divided by 0.212, then you will get this value, and so on. So, and then as we have discussed the total number of dimensions we consider, because it is difficult to see the three-dimensional display, three-dimensional space in the diagram, and so we consider only 2 dimensions. And here also you can see in the first dimension itself it is explaining 62.7%, and if we are including the second dimension, then both dimension 1 and dimension 2 are explaining 82.7. So it is good because we consider if it is more than 60%, then we consider the data, then it is our whatever the dimensions are explaining, it is good for our model. So you can see here so we'll consider only these two dimensions. So this two dimension is explaining 82.7% to our variables. And these are the standard deviation 0.029, and this is the correlation coefficient between these two dimensions, dimension 1 and dimension 2, 0.021. So this is the correlation coefficient. So it is explaining 82.7%. 82.7%. Now, what are in the overview of row points you can see here. So these are just like the correlation coefficient. Brands, this is the correlation coefficient. This is these are the mass function, active margin. We have already seen this. I will show you once again. Brands 0.342. Just a moment. From where those value came. Oppo, Vivo and all these things. So these are the active margin in this case. So these are the values you can see here. For the Oppo, it is 0.170, then it is Vivo 0.211, 0.132, 0.061 and then 0.138. So these are for the user friendly, and then you can see here this is for the active margin of this, the mass function, user friendly and all these things. So these are the mass function. We'll go down. Okay. So you can see here 0.324, 0.303, 0.112, 0.176 and 0.086. So these are the mass function of Oppo, Vivo and then Samsung and MI and Micromax. These are nothing but the weightage. Total out of total weightage, this the Oppo weightage is 0.324, Vivo is 0.303 and so on. So the total will be 1. And now how Oppo is related with dimension number 1. It is negative. Okay. It is negative, and for the dimension 2 it is positive. For Vivo, first dimension it is negative, second dimension it is positive, both negative Samsung, and then this MI you can see here, that is the MI, that is both are positive, and the Micromax, the first dimension it is positive and second dimension it is negative. These are the point to the inertia dimension. Now we will discuss this of dimension to the inertia of point. What does it mean? The Oppo relates to the first dimension, that is 53.9%, and the weightage, these are the weightage, and for the second dimension the weightage is less, that is the 21%. Similarly, Vivo in the first dimension it is 70, second dimension it is 15, Samsung it is 13.5 and then 0.734. Similarly, MI 96.3 and 0.007, and the last one Micromax 1.92 and 0.176. So these are the weightage, how these brands are related to one dimension and the second dimension. Now you can see similarly, like the row column points, row points, overview of row points, you can see here the column points. Row points are related to the brands, and these are the related to the attributes. These are related to attributes. So these are the mass function of each attribute. So we can see here mass function of each attributes. You can see in the row column. You can see here in the column profile. In the column profile, you can see here these are the mass function. These are the mass function of these are the brands, and for the attributes, these are the this 0.156 for user friendly, 156, 0.133, 0.188, 0.149, 170, 110 and 133. These are for the attributes and these are for the brands. So you can same thing we have discussed. You can see here these are for the brands 5, and below part you can see here these are for the attributes. These are the mass functions. How the weightage of one attribute, first attribute is 0.156 and so on. So these and the total value should be 1. The probability value should be 1. Now the user friendly is in the dimension 1, it is related to 0.490 and this is positive. Similarly, this is negative, positive, both are negative, both are positive. Here in dimension it is positive, here it is negative, positive, and then it is negative. Here it is negative and then positive. How these attributes are related in the different quadrants that it is showing. Now how they are related to, how they are explaining the dimension 1 and dimension 2. The user friendly explaining dimension 1 is 80.6% and then 8.7% to dimension 2, and this is the total value. Similarly for great camera, for long lasting battery, after sale service, it is explaining for dimension in dimension 1 it is 78%, dimension 2 16%, 8.1 74.7 and so on. So these are the values. Okay, now the main table we have, it is this, you can see here. We'll double click it and then we'll put a x-axis and y-axis. It is not in 0, so we'll convert it into 0. You can see here it is in 0.5, so I'll put it here 0 and then apply. Okay, then I will put a line, horizontal line. Okay, it is again in minus 0.5, again it is not in 0, so I will put here 0, so and then apply here. Okay, so and then close it, and then close it. So you can see here, so it is showing that in the row wise, in the column wise, Vivo and Oppo are related. These two brands are related, whereas these two brands are not related with Micromax, MI and then Samsung. Samsung is also not related to Micromax, neither the Vivo, Oppo nor the MI. So that is the idea we are getting from this display. From this display, this is related to the brands only. This is related to brands. In the row wise we have seen. Now we'll see the column wise. In case of only attributes we are talking about. Again we will click, double click. We'll give a horizontal line. It is exactly in 0. No need to do anything. And then vertical line. It is not in 0. We'll do it 0, 0 and then apply. And then apply. Okay. And then close it. And then close it. So we have got this. So you can see here a great camera and user friendly, these two things are related. You can consider this competitive price also. Long lasting battery and crystal clear display, these are related. But this after sale service is separate from all the other attributes. These are not related. These long lasting and crystal are related. Somehow this crystal clear and this enough storage space are related. But so many attributes are not related to each other, like a great camera and after sales service. These are the two different attributes it is saying. These are not related. Now our main table is the association between the brands and the attributes, the interaction effect. So we'll double click it, horizontal line 0 and then vertical line, again it is in 0 and then we'll close it. Now you can see here. So this is the green color. It is a brands, and then these attributes are in this color, purple color. So you can see here. People relates MI with enough storage space and then after sale service. Okay. So MI, they are saying that in layman language, you can say that for the MI, they are saying after sale service is good and enough storage space are there in MI smartphone. Whereas the Vivo and Oppo, they are saying that these two brands are user friendly, they have the great camera and they keep competitive pricing. Okay, but they are far away from the after sale service. So what is the logic? What these brands should do? They should improve their after sale service. They should improve the enough storage and then also long lasting battery and then crystal clear display. So people are not relating the different attributes with the Samsung. So all the attributes are far away from Samsung. Means what? So Samsung is not giving proper service to the customers. The attributes of Samsung smartphone are not good. So Samsung has to work on the different attributes. They have to improve all the attributes so that they can attract the customer. So these are the things you can interpret from this multidimensional space. Now we'll go to our PPT. And we can see here we can our result, how to write the result. Same thing you can see here. These are our output. Same table we have already discussed in the SPSS output. This is our correspondence table. This is our row profile. These are the active margin and the weightage. This is the mass function. These are the weightage of the 7 attributes, active margin you can say. Then these are the weightage of the brands you can see here, right hand side, mass function. And then these are the summary table you can see here, this the chi-square value, all are the singular value, the R value you can say. Then this is the inertia square of R value, and these are the accounted for percentage. So we have already discussed how to calculate this. Then you can see here, this is the overview of row points, this is the mass function, and how these brands are going to dimension 1 and dimension 2, and what are the weightage going in dimension 1 and dimension 2. Similarly for the column points, then you can see here we have discussed this, Vivo and Oppo are related. Then we have discussed the attributes, how one attribute is related to the other. Then finally we have discussed this, the Vivo and Oppo people relate, like Vivo and Oppo are user friendly, great camera, competitive price. Micromax relate with their the customers relates with crystal clear display, long lasting battery, enough storage space. MI, after sale service. Wherever the brand is far away from the attributes, that brand has to work on these attributes. So that is the meaning. So what is the final result we can say here? You can see a reporting of result. So the data collected for analysis holds all the assumptions of correspondence analysis. The chi-square value is 215.430 and the significant value is 0.000, which is less than 0.05. It means there is a relationship between brands and attributes. In the row column points analysis, it has been observed that Oppo and Vivo relates with the attributes are user friendly, competitive price, a great camera, and long lasting battery. Whereas the Micromax relates to long lasting battery and crystal clear display and enough storage space. Whereas MI relates to after sale service and enough storage space, and the Samsung relates to crystal clear display. So the Samsung is relating only one. So and this attribute is also the distance is more from Samsung. So Samsung has to work for all the other attributes including this crystal clear display. So this is the output or the result we can write for correspondence analysis, and when you will put it in your research paper, you have to put the display also, row and column point display. This display you have to put in your result, as well as all the explanation, whatever we have written in the result, that you can put. Now we'll go for the second example. You can see our second example is this. What is this? Is related to the products and fragrance. So before that, we'll discuss this example. You can see here, this is the example number 2. This is our example number 2. You can see here what exactly it is saying. Case number 2, products and fragrances. A FMCG company wants to know the choice of fragrances on the different product line of FMCG products. The product lines are bath soap, shampoo, hair oil, body lotion, deodorant, and face cream. So these are the 6 brands are there. The data has been collected on 2 category nominal scale, that is yes or no on the choice of fragrances for different product lines. We have collected the data for these products. Now we have converted the case study in the form of a topic. You can see here, customers' perception towards FMCG products and their fragrances with special reference to HUL, an empirical study. So the entire case study we have converted in the form of a topic. Now these are the objectives you can see here. To study the FMCG products of different product lines and their fragrance, to study the association between products and their fragrance, and to find the multidimensional display of FMCG product and their fragrance. So we'll find out this. Okay, so this is the data we have. You can see a corresponding table. Directly we have written this. These are the products: bath soap, shampoo, body lotion, hair oil, deodorant, face cream. So these are the products, and then these are the fragrances: rose, jasmine, sandal, lily, menthol, and lavender. So you can see your bath soap. So 130 people are saying they like rose fragrance. Similarly, 30 says they like the jasmine, sandal, and so on. So these are the data frequency table we have got. Now we'll go for the data analysis. You can see here our second example is this. Directly I have put this data. You can see here these are the 3 variables I have defined: product, fragrances, and then frequency. I have already defined this. You can see here bath soap, 6 product lines are there: shampoo, hair oil, body lotion, deodorant, and face cream. I have already put the value, and then fragrances also you can see here. There are the 6 fragrances are there. So we'll okay. Now you can see here. If you click here, you will find out all the products and fragrances are there. I will click here 1. Now I have told you that you have to convert the data into weight cases. For that you have to go to data, and then you can see here the weight cases, and then weight cases by, and then the frequency you have to convert it into frequency variable, and then okay. So in the output you will get, you can so we have to close the earlier output. Okay, so weight cases we have converted the data. Now we'll go to analyze. Then we have to go to dimension reduction, correspondence analysis, and in row we'll put products, define range. We have 6 product lines, 1 to 6, and then update, then continue, then the fragrances we'll put it in the column, again define range, that is the 6 fragrances are there, 1 to 6, and then update, and then continue. Now in model we'll go to the, you can see a dimensions in solution 2, chi-square is there. We'll continue. We have done it once. Then the row profiles and then column profiles. Continue. Then we'll go to plots. By plot, by default you will get the combination association. If you want row wise also you will get, and then column wise also you will get. So we'll continue, and then okay. Now we have got the output. You can see here. So this was the frequency table already we had with us when we have collected the data. These are the row profiles. You can see here, these are the weightage. Total weightage for bath soap, rose, and all these things will be 1. These are the active margin. Here this is the mass function of all the fragrances. So this is the mass function you can take. Then the next we have already discussed in the previous example. This is related to the bath soap. Bath soap, shampoo, hair oil, these are related to products. These are related to products, and these are the mass function of products. You can see. Now again you can see here. So this is the R value, correlation coefficient value. All the variables are related with the dimension 1, this much, dimension 2, dimension 3, dimension 4, and then dimension 5. How the variables are relating with dimension 1, dimension 2, dimension 3, dimension 4, and dimension 5. So this is the correlation coefficient. If you will square this 0.596, you will get this value. If you will square this, you will get this value, and so on. And then this is the total value, and this is the chi-square value you can see. And this is the, again it is significant. So there is an association between the products and the fragrances. So that we have understood. And then again, how, from where you will get this value 0.648. If we will divide 0.355 divided by 0.548, you will get this value. Second divided by this, you will get this value, and so on. So in the first dimension itself, it is explaining 64.8%, and if we will combine this second dimension, it is explaining 85.6%. So we'll consider only 2 dimension. In the earlier part also, in the by default in correspondence analysis, it will give you 2 dimension, and these are the standard deviation, and these are the correlation coefficient between the dimension 1 and dimension 2. Similarly, you can see here, these are the row profiles, mass function, how it is going to the dimension 1 and dimension 2, and how much percentage it is relating in dimension 1 and dimension 2, all the products. Similarly, for all the fragrances, you will find out, and then these are the how they are going in the dimension 1 or dimension 2. These are the mass function, and here how much percentage contributing in dimension 1 and dimension 2. So this is the total value. Now this is for the row wise, it is only for the products. You can see here how these brands are relating. And second, you can see here, hair oil, deodorant, and face cream are nearer to each other, whereas body lotion and shampoo are nearer, and bath soap is alone somewhere. So these 2 are relating, these 3 are relating, and then bath soap is not relating with any of these 2. Similarly, for these fragrances, lily and jasmine are relating, and other are all at the different places. So the fragrance are not relating with each other. Now our final table will go. So this is our final table, you can see. Now I will put a x-axis in 0 and the y-axis. Okay, and then I will close it. So you can see here this is it. So what is the explanation of this particular aspect? You can see here people relate bath soap with sandal. So they want sandal fragrance if they will go to buy bath soap. So any company, if they are making or manufacturing bath soap or producing bath soap, their fragrance should be sandal. Similarly, for the shampoo, they relate with the menthol fragrance. So if you are a shampoo manufacturing company, so your flavor should be, your fragrance should be menthol. Similarly, for the body lotion, your fragrance should be lily and jasmine. So if you are bath soap you are making, your flavor, your fragrance should not be lily and jasmine. So the lily and jasmine relates with body lotion. Similarly, you can see here hair oil, deodorant, face cream, all are relating with what? Lavender. The hair oil is relating with lavender, deodorant is relating with rose, and the face cream is also relating with rose. So if you are making fair oil, manufacturing fair oil, your flavor or the fragrance should be lavender, not like sandal. So this is the output or the inference you can do it from correspondence analysis. So this is we have discussed about this correspondence analysis, and in the same way you can write for the second case also. The output result you can write for the second case also. So that's it for this correspondence analysis. We have considered two examples. Thank you.